Okay, so for the second part of homework 10, we are modifying the traffic light so it counts the number of cars that trigger the sensors. So I select option 1. Um, Again, I was trying to do the timer, but for which is option 5, but that didn't really fall through as well. So I went ahead and tried to switched over to the traffic light and went with option 1, which we're just counting the cars that pass through, which that are only the ones that are triggering the sensor. Um, and moving forward to the VHDL. Um, actually before that, we can look at our FSM in which we're actually referencing. So for this example, we're going with 14.6. It has both car east-west and north-south sensors. So it's the best option out of the three, where I don't have to add an extra sensor. We already have our two. So, and here we have 4 states. Pretty much everything is fairly much the same. The main difference again is adding in the car counter, and this car counter will count for both north, south, and east, west cars. So we'll just have our one counter here, 5-bit counter. So just set 5 bits because that's kind of what I use in my vending machine as well. 5-bit counter, or just whatever. Might as well count 32 cars, I guess. And then moving down to our architecture, we have our added signal here, our 5-bit signal. And that comes into play again. You still start simulation with the resetting clock process, precedes in that state that's your clock, just like so. Pretty self-explanatory. And then moving on to our process where we added our extra line of code was here, in which we are counting our car that triggers the east-west sensor. So in our initial state, our output is 100001, which means the north-south light is green and the east-west light is red. If there's no car in the east-west, then we continue to be in our state. We allow cars to continue to pass through a north-south lane. If a car is present, then we will count that car first, and then we will move on to a state 1, in which we would move on, in which the light would change to yellow, east-west light will remain red, and then we will move on to both lights being red, or north-south light being red and east-west light being green. And here is the same thing. If there's no car present at north-south, we will remain at the current state. Otherwise, if there is a car present north-south, then we will count that car here, and we will proceed to state 3. And state 3 is as follows: north-south is red, east-west light is yellow, then process return to initial state. So that's what's going on here. And then we tie our car count to our CC1, and lights and OP, and yep. So moving on to our test bench here. Again, the only really change was our car count 1. So we just go ahead and put our component here. We added our counter, and we went ahead and added our extra signal, routed those together, car count 1, and we just did the same exact test bench pretty much. I just changed some of the values, 5 nanoseconds, just because, yeah, pretty much the same. Here we're going to be going into our simulation, and as you can see, whenever we do get to car east-west is present or car north-south is present, then we will count those cars, and our car count goes off. And yeah, so we start here, move on to 3, and then it counts 4, 5, 6, and we continue that pattern on down while clock cycle, and each time a car east-west and north-south is present. Thank you.